Welcome to my presentation about patterns for migrating OpenEdge Web Client GUI to stateless web applications. Most of what I'm talking about in this talk are, experiences from modernization projects where we support OpenEdge application partners, VARs, or direct end customers in modernizing OpenEdge applications. I say Web Client GUI, most of the same applies to TTY applications too. Patterns, what are patterns? Patterns are typically referred to as, common solutions to common problems in software development. So let's start by introducing my company, Consulting Werk. We are supporting OpenEdge developers. We're focusing on OpenEdge and related technology. We're using a lot of the Kinvey products. We're using Tilric products and these kind of things to help customers typically modernizing OpenEdge applications. We're working out of Germany. Cologne is our main office. But we also have people working for us out of the UK and Romania. Most of our customers are based in Europe. But we also have customers here in North America, Australia, and South Africa. We provide consulting services to our customers, but we also provide tools, a developer framework, the Smart Component Library that I'm going to introduce tomorrow in the presentation is very often the foundation for the modernization efforts that we do with our customers. Well, there are a couple of areas where we are specialized in. We were a very early adopter of OpenEdge GUI for .NET. And for a long time, I think we've been recognized as being like the go-to guys when it comes to GUI for .NET and OpenEdge and using .NET technology for the UI. When web technology became more and more relevant and programs acquired Tilric, we've also started gaining expertise in these areas. And object orientation and language, software architecture, all those are areas where we provide support to our customers too. The Smart Component Library framework, just a few words on that. It's a developer framework, and we believe that it's a very great vehicle to support OpenEdge application modernization. It allows us to integrate with any existing code that's already there. It's not a black box. We have a lot of functionality there, both for application functionality that works in distributed architectures and for application architecture itself. That all can be used in pieces as needed. It can all be integrated with functionality that customers may already have. So it's not an all or nothing approach. It's not a black box. It can be used, tailored, made to fit to the requirements of any modernization project. It follows the principles of the OpenEdge reference architecture and the common component specification. And through that, it just has proven in the 10 years that we're maintaining this product now that it helped us to adopt to a lot of changing requirements. One of the things that we provide with the Smart Component Library is user interface flexibility. We started developing the Smart Component Library to make leveraging the .NET Windows desktop user interface technology for OpenEdge applications easier. But we've adopted the framework to support a number of other user interfaces, either developed by ourselves, like our client based on Angular and Candy UI, or our client based on Progress's native script. We provide a lot of open standard UI, APIs to the business logics that can be used by customers to build their own UIs. And we have partners that also provide UI technology like Axioma. And tomorrow there'll be a talk by Shelley Chase about the different UI options, and that's where you will be able to also see our web UI and Axioma's web UI in comparison. Some of the aspects I'd like to talk about, and I need to hurry on a bit because the time is very limited in this presentation. So I want to talk a little bit about the modernization process. So what does it mean to run a modernization project? And what might be strategies for running a modernization project successfully. Then I want to briefly talk about application architecture, what I believe is the right architecture for the OpenEdge part of a web application, how business logic can be exposed to modern web applications. Well, a brief discussion about PaaS-OE or web speed, but to keep that very short, for modernizing modern web applications, classic web speed is no longer an option. A process retired that product. So every modernization approach going to the web should start with PaaS-OE, period, regardless of which OpenEdge version you're on right now. Context management is a concern, record locking, how to deal with validation, and input blocking is an interesting aspect in many web applications. So let's get going. When customers talk to us about modernizing their existing GUI applications to the web, then the first question is always, well, which parts of your application do you want to modernize to the web? And do you take an intermediate step? Some customers know that they need to modernize the whole application from GUI or GUI for .NET to web or mobile UI. And if that's a well-thought decision, then that's okay. Others are not so sure about that, and there are many aspects which have a role there. It starts with, well, what are the devices that your users are working on? What kind of integrations do they need? Web technology can be quite complex when it requires integration with local resources on your local PC. And if the user is working 8 hours a day on a PC UI might still be a valid option. But there are other applications where web UI just has a lot of benefits. A lot of customers decide to first start with building some smaller applications around the big, let's say, ERP system, whatever the core application is, just to gain some experience with the technology and reduce the risk and be able to quickly react to changing requirements and changing technologies. We have customers that say our infinitive goal is that the whole ERP system should be migrated to the web. But if you try to do that in a big bang and say, well, we need to release the whole application in X amount of months or years as a web application, that's a very, very big step to do. It might be a better option to start by saying, well, we first app server enable our GUI application. Because while we're doing that, we prepare the application backend to be reused in a web application. And we can keep on making changes to the backend business logic to keep it current with the user's requirements. And then at the end of that journey, applying a web UI to that might just be so much easier. And another challenge with web technology that's quickly changing, if you say, well, my modernization project takes 3 or 4 years, and you start today a web application development project, which you will be having completed in 4 years, I can promise you that the technology change you make today for the front end will be so outdated in 4 years. So by working on the back end first, and then have a much smaller adoption period for whatever the web technology of in 4 years, I'm pretty sure that you reduce the risk of such a project dramatically. And well, those are discussions that we start with our customers. So when we first go from GUI or TTY to an app server-enabled application, NT application, we are preparing the backend for much faster adoption of web UIs in the future. Another thing that we also try to understand is, well, who's driving the demand for going to the web? Are it really the users? Is it the IT organization? Because they might have some problems with deployment that might be solved elsewhere. Using other technologies, other strategies too, or is it the marketing that believes we have to be on the web, otherwise we cannot sell the application anymore? It's important to be very clear about what is your minimum viable product. So how much of the functionality of the application do you need to migrate to the web in order to be relevant for the user? If you are working towards a step-by-step migration, your users will be very annoyed if during an average working day they have to permanently switch between your existing GUI application and very few screens that you already have in the web, that the users will just not accept that. Well, that's also a reason why starting to work with satellite applications, where you can clearly define the scope of such a satellite, might be a good starting point. When we're looking at migration of applications, we also start by looking at, well, is the existing application in the source code a good enough starting point? Would it require functional changes? Would it require major changes to the database? If we talk to a customer and he says, well, there are so many problems in our database design, and we want to fix that while we're going to the web, then that just breaks a lot of chances of reusing existing code because, well, the beauty of 4GL or ABL code is that it's tied so closely to the database. But at the same time, what we just have to be clear about is that for most applications, and that's probably not just the case for ABL or OpenEdge applications, the only complete functional description of what the application does is the source code. So very often we experience that developers that want to rebuild functionality using a new UI technology or whatever, they have to look at the existing source code to understand what the application is doing, because otherwise they wouldn't have a written down description. So the source code becomes part of the requirements. It's very clear. The other thing that we frequently experience as well, when we start such a modernization project, we have to introduce tools, new development processes, maybe things like unit testing, DevOps technologies, etc. That is a big challenge, a big learning curve for any developer. And there are developers which are just quicker at that, but still a challenge for them, and there are developers which are really challenged by that. So it's something, a huge risk that we see very often, that the learning curve for the existing developers is really underestimated. And well, the best way to avoid that is to work with people that can teach the team, well, companies like us or Progress Professional Services or whoever. Well, it sounds like self-marketing, but I'm really convinced that that's the best way to do such an enterprise. One of our, well, actually our biggest project so far, it's a project for an organization called the OSC, the OSIF Service Center. It is a Swiss government organization maintaining an application for the state insurance of occupational disabilities. So they're managing the process of well, applying for, I don't know, starting from I need a glass to be able to continue working on a computer, or I've lost an arm and I need some support to be able to get back into a shape that I can work, or all sorts in between. And what they do is they approve therapies, they approve billings from doctors, and stuff like that. It's a heavily document management application, well, paperless. Whenever they get paper into their organization, they scan it and they don't have to use the paper anymore. It's an OpenEdge GUI application used by 1,300 users in 7 of the Swiss states. And they decided to modernize for a number of reasons. One of the reasons was the satisfaction of the developers. The developers haven't just been satisfied anymore to maintain the old code base. And they also realized that, well, we can't adopt new requirements from the users that quickly anymore. And that all did lead then to the decision to start a modernization project. And in that project, they also realized that the existing 1,300 users really love using the application. They know it in and out. But it's like probably most of the OpenEdge GUI applications I've seen, a very crowded user interface that once was designed for 800 by 600, and they have buttons on the screen wherever there was room, and buttons have context menus, and the users knew I have to right-click that button, go down and into the next submenu, and there is the functionality that I need each day 50 times. teaching that to a new user is challenging. The new users are saying, well, what a mess. And yeah. So what we started there, or what OSIF did decide to do there, is the so-called, well, what we call, many people call soft migration. The decision was made to keep on using the current application, using the database, and in parallel, implement a new web application using the same database. And we defined a couple of rules. We needed to maintain source code compatibility, so it's not a problem to recompile the existing application, but we couldn't break the existing source code. So for the database, it means the database could grow. We could add fields and tables if we needed to support the new application. And one of the things that we, for instance, did is we added something like a GUI key to every table, because we have in the two frameworks used there a lot of functionality that works best if you have such a modern key. But the existing source code still works against a lot of well, human meaningful keys. And then we added the databases of the frameworks. And step by step, then we replaced the existing, or we are replacing the existing screens with screens in the web. And we've defined 4 or 5 releases, and each of the releases is defined around the minimum viable product for a certain set of roles in the organization. So the first set of users will have almost all of their functionality covered by the first release. The second set of users will then be working with a second release, and so on and so on. And we are harvesting a lot of existing code. And that's part of the complex business logic and improving the processes there, and yeah, following legal requirements. And none of that is documented anywhere else. So the harvesting of the existing code here is basically done by copying, pasting existing code from .ps or .w files into an OERA compliant application, so mainly into business entities and business tasks or similar sort of service objects. So which brings us to the question, well, what is the target architecture that we recommend there? Well, and we still believe that the OpenEdge reference architecture is a very valid starting point for defining an application architecture. A couple of years ago, well, 15 years ago, the OERA was like an architecture blueprint for service-oriented OpenEdge applications, and at the time it served a certain goals. It should provide support for going to the app server, building non-monolithic or not so monolithic ABL applications. It should support client flexibility, providing guidance for using pro datasets and other language features like object orientation. So a lot of that is still valid today. And well, a few years back, Progress started another initiative called the Common Component Specification, where the principles of the OpenEdge reference architecture have been updated a little bit and defined to a much more detailed level to software specifications, allowing to really code against them. The OERA was just, well, a blueprint, and the CCS just moved 2 steps further and said, well, we are providing technical specifications and so much closer guideline for developers. And an interesting thing is that Progress is also using the Common Component Specification. Some of the features that are implemented as part of OpenEdge 11.7 and 12 are following the CCS principles as well. The web handlers of PassOE, for instance, they are managed using the CCS Service Manager, and that is a very interesting concept because it allows us to extend that functionality very easily. A key concept there are business entities as a business logic component. And what it is, in short, well, it's a class, typically a class that manages a set of database tables. And it should be the only place in the whole application where you will be maintaining data in those tables. And And so it provides all the CRUD options as a service object. You can have other functionality in there, like processes, like shipping an order, small business tasks. And if you look at a lot of the front-end technology provided by Telerik, they can use the JSDO, a JavaScript component, to interact with business entities, and that's just a very nice fit on the front end and the back end. If you look at the architecture diagram, then we see, well, the OERA diagram redefined. We have the business components where the business entities and the tasks are just the typical areas where you would be harvesting existing code into. Then we have service interfaces, and the service interfaces basically have two roles. They should be exposing the business logic in a form expected by a certain client technology. And there you can solve a lot of common infrastructure tasks like authorization, authentication, and logging, context management, etc. Because I'm a very, very strong believer that within the business components, you should never, ever code against a specific client technology. That means, for instance, even though all of the web UIs that we're using today are speaking JSON, I would never, ever expose anything using JSON from within a business entity. Because I don't believe that in 5 years from now, JSON is still industry standard. There will be something new. I don't think it's the end of the journey. So the business logic should not be coded against any front-end technology. So that's the role of the service interface. And the typical roles, as I said before, well, it's the bouncer who decides whether he lets you into the club, and the Babelfish who does all the translation between the data or the message structure that a business entity understands per data set and whatever the current consumers understand. Might be JSON, might be XML, might be any other data format. So that's really one of the most important components for me in these architectures, is to have a clear definition of the service interface. So how do we expose business logic? Which protocols do we use? And typically, when we're using Telerik front-end technology and PASI on the back end, then we have a choice today between RESTful and the JSDO. Both are using HTTP for communication and JSON as the format for the data structures. So there are a lot of similarities, but RESTful and the JSDO are expecting a different semantic in the form of how they interact with the backend. And we had a very, very good, well, we still have very good support for the JSDO in our framework. We thought by that, hooray, we have the JSDO, the JavaScript component maintained by Progress. We can make every web developer happy. But we had to learn that if an organization already has web developers or hires web developers, maybe an outside company that has done web development projects outside of the PaaS-OE backend, they don't know the JSDO. And they say, well, why should I learn? The JSDO is a very Progress-specific interface to PaaS-OE. Why don't you just provide us the business logic and the data in the standard that everybody else is following? And that is RESTful. So within the PaaS-OE backend, Telerik front-end world, the JSDO, I think, is the right choice. But everywhere else, you need to be prepared for RESTful interfaces or people asking for RESTful interfaces. So it might be required to be able to support both, a mix of both. So what's the difference there? Well, RESTful is an addressing scheme for interactions between a client and resources. Resources are more a representation of data. A customer is a resource, or a list of customers is a resource. And there are standards for how clients can interact with this data through HTTP. The HTTP verbs, it's part of the HTTP protocol, actually define what the client wants to do with the data, whether he wants to just read data, update data, create new data, delete data, etc. Well, if you think of classic web services were more were more invoking operations that returned you data, and here you're addressing data. It's a different semantic. How it looks like, the client might be requesting data by the address of the server, the name of the collection. The names of the collections are typically plural verbs, and if it's a single customer, it would be providing the unique key of that customer. If it's not adding a key of a customer, like in the second line, then it would be requesting a list of customers. And in this case, it's read like, well, out of the list of countries, I'm picking South Africa in that case, and I want to have the list of all the customers in that country. So that's one example how RESTful clients would be addressing data. And yes, on the end, we have to translate it into queries and all this stuff. But web developers understand these forms of requests, and they're quite happy when they see that. The JSDO, on the other side, well, that's a JavaScript library developed by Progress. It's there since a while, since 11.2. I think that's 7 or 8 years ago. Yeah, whenever talking to Telerik UI components, the JSDO is just a very, very good choice. Things like Ken UI Builder, the Telerik platform, all those have been using the JSDO for accessing data. And you can use it with things like TypeScript or native script. And yeah, it's a open source component, royalty free, and it maps very perfectly to some of the specific properties of the Pro data set. It has its requirements. It requires a data catalog that describes which fields and tables are exposed. So it has a certain query standard, how filtering is being sent to the backend, and yeah, just a different interaction scheme with the front end. Well, PaaSOE, to keep that very short, or WebSuite. Everybody who's still using WebSuite or has been using WebSuite in the past, it's time to say bye-bye. There's no classic WebSuite anymore. OpenEdge 12 just provides PaaSOE. PaaSOE can run most existing WebSuite applications with no or little change. And also for a GUI or TTY application, if you're using the app server, the migration to PaaSOE, sometimes you need to change some code and you need to learn different configuration and all that stuff, but it's not a big change. And one of the very, very nice concepts in PaaSOE are web handlers. A web handler is a very flexible way of implementing HTTP-based APIs. It's a class that you implement, and in this class you have access to the complete HTTP message that you receive from the client, and you have full flexibility of what you return to the HTTP client in a way that wasn't possible with the classic app server before, and also far more flexible than what WebSuite could be doing. Something, it can support HTML page generation, but when we look at modern web applications, what the clients are actually doing, you do not require a backend anymore to generate HTML for you. The dynamic HTML is typically rendered in the browser by, well, frameworks like Angular or whatever other single-page application frameworks. So passive web handlers are a great way of flexibly exposing processing logic and data to web-based clients. We do have some examples that implement very simple RESTful services using PaaSOE web handlers that you can download there at GitHub. Well, they serve for many of our customers as a starting point for RESTful services. Yeah, context management. Context management is a requirement for most applications. What is application context? Well, it starts with who's the current user. what's the login company, what's the language of the user. Maybe you have screen context. When you go into one screen and back out and back in, the user expects that the selection that they had done earlier is still there. It might be a web card if you're delivering more like a shopping application. The web card is part of the screen context. And typically that's transient information that's scoped to the current user or user login session. And in existing GUI applications, you typically, well, how do you deal with context? You might have global shared variables. You might have information persistent procedures or class or whatever, all these kind of things. In a web application, in an app server application, it's a little bit more complicated to maintain context. What we like to use or prefer to use is PaaS-OE, then with a form-based login model. It's when you look into PaaS-OE and authentication, there are different login models and they have different specific features. When you use, for instance, the form-based login model, PaaS-OE automatically maintains a session context for us. The session context contains or provides us information like who is the authenticated user. Well, basically free of charge. We don't have to do anything for that. And it's based on client principles. Client principles have been introduced in, well, OpenEdge 10 point whatever for auditing first. And in newer releases, they are the foundation of identity and context management. So based on that, we can work with other contexts. The client principle that we get automatically by the PaaS-OE is something that we cannot change anymore. Once the user is identified, or during the authentication, you can add properties to the client principle. But one of the key concepts is all of that state is not changeable. So if you have application state that requires to be changeable, then you can still leverage a session ID provided by PaaS-OE to us free of charge. And based on this session ID, you can very easily implement your own context management. You can store session context in a database table and use the session ID as the key to that information. We have other customers that feel better with writing session context to files on disk because they feel, well, it's transient. We don't create records that we delete, and it's not the best thing to do to a database, permanently creating and deleting records. But anyway, in any implementation, the session ID provided by PaaS-OE and the client principle can be used then as a key to this. So, and how has that been done in, well, very old applications? And at every customer, we meet those. Global shared variables or shared variables. Shared variables, those that have been using shared variables as for context, like users and login company, think they've been abusing them. Shared variables have just been a workaround for the lack of input-output procedures in version 4 of Progress. Was it 4 or 3? I don't know. They shouldn't have ever been used for application context because they depend on the state, on the call stack. And global shared variables, they are less trouble. Global shared variables can be used for who's the user, who's the login company, much better. And also moving forward, it's a much better way of doing that. The big challenge with both of them is everybody believes that going forward, a lot of the new code should be class-based, and class-based code doesn't have access to any of these shared constructs. It's just a matter of fact. So what can we do there? When we have a situation where we have a PaaS-OE web handler that provides access to a business entity, and that might be calling a database trigger procedure that is also still used by the existing application, then we may have discussions with customers saying, no, we can't change that database trigger. It needs to keep using the global shared variable, so to know who is the user, for instance. With the global shared variable, it's quite easy. we can use the activate procedure of the app server. It's a procedure, so it can access the global shared variable. It has access to the client principal. So there we can basically just read the client principal and assign the global shared variable with the user. That's very easy. With shared variables, we have a problem. The activate procedure is not in the direct stack trace of the database trigger. So if you would define a new shared variable there, it wouldn't be accessible to the database trigger. The database trigger would say, well, the variable is not new shared defined. So then we're going to the class here to call that class. And in order to work with these shared variables, the ugly thing that we have to do is we have to call from this class, not straight into that class. We need to go through a procedure. That's really awful. So that's the point where we typically have discussions with customers whether they couldn't fix the shared variables used for context at least into global shareds, because usually that's what they were meaning to do. Well, record locking. Pass-through web applications are state-free, and pass-through has no concept of record logs or transactions spanning multiple requests. It's not there. In the very old WebSuite, it was there. I think WebSuite version 2 had a concept for that, which was a bit challenging because you never know whether the browser really comes back. So in Pass-OE, you just need to live with the fact that this is not there. Within a single web request, however, record login transactions behave like they've always done in the ABL. There's no change. It's just ABL or 4GL code. And before we look for a solution for record locking, we have a discussion with the customer. For which purposes are you using record locking? So is it to avoid that users unintentionally overwriting data? Maybe during a processing block, you verify some data at the beginning and you want to know that this is still the case at the end, and that's why you have to lock records. But that's typically within a single request, so the traditional record locking works. Maybe you use record locking to stop users from doing the same stuff in parallel, like a month-end transactions. You want to make sure that when one user is running the month-end transactions, no other is doing that. And I've seen application where that's done by locking the login company record also. And what I've also experienced when it comes to the unintentional overwriting of users, of data by users, that this is really so important to developers. And they believe it's really, really important. If you ask to users, do you actually care if you press save and your neighbor presses save shortly after on the same record, that he might have changed the street and he might have changed the city of the customer, and that might be leading to a not so clear variant of the record? Most users will tell you this is so damn rare that if it ever would happen, we don't care. And that's an interesting discussion when users come into the picture and they say, we just don't care. And in the end, I believe the application should be working for the users and not just for the developer being proud on, yeah, well, that screen is open, no other can be in the same screen and log the same data. For most users, it's more annoying that they will be getting messages every now and then, you can't make that change because somebody else has that record open. So record locking is really something where I learned it's wise to first ask which sort of locking do we still need. When it comes to implementing locking, something that works very nicely with the JSTO and the Pro dataset is optimistic locking. Optimistic locking is a way of not blocking exclusive access to a record. It's more, once you actually want to commit it to the database, verifying if nobody else has changed it in the meantime. And that concept has already been implemented in the ADM2. The STO had a concept of that, and the Pro dataset with the Safe Road Changes method provides that too. And then if you put the JSTO on top of that, most of that optimisting just works with very, very little code you need to implement in the backend. But also there you need to ask yourself whether the users need that. If you're not using the JSTO, if you're doing RESTful clients and you need optimistic locking, then you need a way to simulate that based on timestamps, so you could verify whether in the meantime the timestamp of the record has changed or record version or whatever, and keep those stored in your session context so that you know, okay, when I did read that record, it was version 5.0 of the record. Now I'm trying to save it and it's changed to 6.0, so somebody else must have changed in the meantime. So you need a little bit of information in your session context to do that. The more critical thing when looking at existing applications or interacting, sharing the database with an existing application is how do we deal with long record locks performed by those existing applications? Because in the past, it was just common practice to do that. And a Progress GUI client would just show the message record is in use by another user, and you could press cancel and so on. An app server process would wait for quite a long time. When you try to lock a record exclusively and you're not using the no wait option, Progress waits for the duration of the LKW TMO parameter, the lock wait timeout parameter. Unfortunately, the minimum was 10 seconds. A good principle for web requests by any browser-based application is they should return sub-second. So the 10-second lock wait timeout means you would try to save a record, and the app server would run into a record lock, wait for 10 seconds before it comes back to you. That's not a good behavior. So either we should try to get Progress to provide a sub-second option for LKW TMO, or you need to try to lock records with no wait and handle that yourself. When it comes to working with record locks, you should also be on a very current version of OpenEdge, starting 11.7.4 and 12. There are significant improvements in the AVM in handling lock wait timeout situations by integrating those stop conditions with structured error handling. Yeah, and in some cases when we need this locking of resources, which could be a single record or which could be like access to a function, then what we very often implement is some sort of a logical locking, and that just means within the application or the application framework, we have a functionality that allows us to lock records, and it might look like this. We're obtaining a reference to a service object, and that might have a method there to acquire a lock. And this functionality, when you get the lock, so when nobody else has that resource locked, it returns you true. And if not, it could either return you false or throw an error. And then there's a functionality to release the lock. And with this, in the context of a session, we can implement in those rare cases where we needed a longer record locks or resource locks, which are longer than a single app server request. But generally, we try to use this functionality with care, because we don't want to run into too many deadlocking situations where browsers that may never be coming back having locks, and users that really want to do something are waiting for that lock to be released after a period of time. Validation, in short, when you write client logic, you can write a lot of functionality in JavaScript or TypeScript. And you can also write validation there, but never trust the browser. Never trust the client sending you properly validated data. First, you're exposing functionality through an open protocol, so you never know whether your browser application is sending you data that has been validated. Anybody else can talk to that endpoint too. And the other thing is the code that's executed in the browser every browser that you're using, Google Chrome, Microsoft Edge, Firefox, brings debugging tools within. So every user can go step by step to your code and change the values of variables. And yeah, you don't have control over it. It's not a locked application like R code of a GUI client that you had in the past. So that's really something. You always need to validate everything again on the app server. Well, let's skip over that. I can briefly mention the last topic. Input blocking. Input blocking is something that many applications use also in validation. What is input blocking? Input blocking is you're running a routine, and the routine just needs to get back to the user. It's the message statement, typically, when it comes to validation, or it could be starting a dialogue, anything that did the wait for statement, and so on. PassOE cannot get back to the front end and wait for the front end to get back. It's not possible. Whenever the app server wants to get back to the front end, the current app server request needs to end first. But sometimes you need to ask the user of the front end something. An example. The front end issues a delete request for the customer, and I think in the Sports 2000 demo application, there's in the delete trigger an if can find open order, then, well, open order exists, delete anyway, yes, no. So you may find this in your existing code. What do we do with that? One alternative would be on the front end, when you press the delete button, you show a dialog. And in that dialog, you first ask, are you sure to delete? And you have a checkbox. If this happens, then perform like that. And then as part of the request to the delete functionality, you have an attribute saying, well, if there's an open order, delete it. So then the backend knows how the user would have decided in that place. And that's okay when you know there are not so many questions. Because if you have complex business logic, and you would have like 20 decisions, if that happens, do that. If that happens, do that. And most of those situations would never occur. This is annoying to the user and also dangerous because the user would never pay attention to that. So we need a different solution for that. And we had a lot of those cases in the OSEF project. Because of the demands there to reuse the existing business logic, we couldn't change the processing logic completely. We had to live with the fact that we run a validation, and after 100 lines of code, we have a question to the user. And based on how the user replies, we go that direction or that direction and might run into the next question. So, but we're using the JSTO, we're using PassOE, we're using a browser front end. We have to have a solution for that. So that's an example of the existing source code. We had here the lucky situation that all of these questions have already been wrapped in an API, but that's not that relevant. That is the code now running in a business entity in validation. And what we see here, a lot of the flow is the same. The code has been changed from procedural to class-based, so it looks slightly different. And what it does is, if an insured person dies while it's having opening request, something happens with the address. The address is marked as, well, you can't send him mail anymore or something like that. And behind this different API, we could implement an API that we had in the framework already to deal with messages in this case. And Bailey, what it does is we have here a question. And we know when we have a question here that hasn't been answered by the user, we consider it being an unanswered question. And then using this code here, we basically stop validating the user, and the framework knows that it gets back to the client, including an unanswered question. And the client knows if an unanswered question comes, I need to show it to the user and try the same request. And when we can keep on doing that, with many questions, because once a question has been answered in that transaction, we remember that answer. And we can identify questions by GUIs. So this GUID is basically identifying that location in the code so that we know it's a unique identification of the question. And so the rest is framework functionality. This is an example of how we return such a question as a JSON structure to the browser-based code. And the browser knows that it needs to display that and get back. And first the reply is unanswered. And later it would be yes, no, OK, cancel, whatever the set of buttons were that belonged to that question. Good. 5 minutes over. I would say if you have questions, well, I'll be around, can have discussions outside. Thanks for your time. And, well, I hope you found that valuable.